roto evaporator, an absolutely indispensable piece of equipment for an organic chemistry lab. As illustrated in the earlier videos, we often end up with our product dissolved in an organic solvent, in which we would like to remove the organic solvent. The roto evaporator, or colloquially the rotovap, is a system that uses a heated water source and a reduced pressure in a condenser that helps boil off the solvent at a lower temperature. To do that, it needs a condenser, which is up here, and a vacuum system, which is here attached to the water aspirator. I've already connected the water aspirator vacuum system, making sure that the condenser is in place. Again, our laboratory hack, we've got a small clamp on the hose, not fully depressed, so water will drain into the sink. And we have an inlet hose, which we attach to the condenser here, or to the water source. Okay. Now, when I turn the water on, we can see that the condenser will fill with cooling water. So the water, again, passing through the hose, in through the condenser. This whole system, this series of coils within the this portion of the rotovap, is going to help condense our solvent. We do not need a massive flow of water for cooling, similar to what we used when we had done a reflux in the previous video. Rotovap has a integrated heat source on 0 degrees, 100 degrees. We're going to be removing diethyl ether. 40 to 50 degrees is more than adequate. On button here will allow us to raise and lower the apparatus so that we can heat our flask, as well as with the rotation button we can get the whole system spinning. So the condenser's on, the power is on to the articulated arm, the hot water bath is on. We now need vacuum using the water aspirator. Turn that on. We use one of these little safety retaining clips when we're attaching the flask to the rotovap. These clips that we use have a smaller collar and a larger collar. The smaller collar fits up top and clicks in place, and now the flask isn't going to go anywhere. We turn the valve here. This is going to help close the entire system off. We move it at a 45-degree angle, and then get the rotovap spinning. I give it a moment or so before the vacuum starts to build up within the system, and then I just gently lower the flask so it's just touching the water. I don't fully immerse it immediately. Diethyl ether has a low boiling point. This water is quite hot. If it boils too quickly under the reduced pressure, we could get both our solvent and our material burping or bubbling into this rotovap bulb, which we don't want. I wait momentarily, give it a few moments. Nothing's happening over the top, and I just lower the flask into the hot water. So as the solution boils, the diethyl ether here under reduced pressure is boiling. You may find some of the vapor condensing in this bulb. That's fine. As the system develops and this material more and more evaporates, the vapor will move up, begin to condense on our cooling coils, and I think you can actually see some now. It's starting to drip down the condensing coil and collect into this flask. It's been several minutes. We're down probably 2/3 of the volume. The last little bit will go quite quickly. I'm just going to fully immerse it in the hot water and give it a few seconds. What we should see happening, different for every system, but today we have the organic material that we have present here will likely show up as an oil and then turn into a white powder, all within a few seconds as the last little bit of the vapor evaporates. Okay, as the solvent starts to come off, the solution gets more and more concentrated, and you may very well see early precipitation. This is always dry because of the level of the diethyl ether, but we expect it to fully be gone in a few seconds. You can see the vigorous boiling, and shortly we should have nothing but solid left in the container. At this point where it looks like there's no clear or no obvious amount of solvent left, I always like to leave it on for another 20-30 seconds. That ensures any trace amounts get a chance to evaporate fully. Now we're ready to remove the flask. To do that, we can turn the hot water off, assuming that we're the last one to use it during the day. Stop the rotation and lift the flask out of the solution or out of the hot water. Now, the entire system is still under vacuum. I'm not going to touch the water. What I want to do is break the vacuum of the system. So I'm going to open the valve at the top of the rotovap. You can hear it pulling in air. As the tone changes and you almost hear no air being pulled in, the system has more or less equilibrated atmospheric pressure. I can take the clip off, and then with just a gentle twist to the round bottom flask, it should come off. Set it aside. It's ready for the next student. If I am the last student of the day, simply turn the power off, stop the condensing fluid, and turn the vacuum off, and we're set. And there we have isolated our material from earlier in the day.